Okay. So if you guys have your notebooks out, open up to your table of contents page. Today, these are pretty short notes actually. These are notes for multiplying monomials to polynomials. So it's the last heading that you see right there. For me, it's page 6. It might be something different for you. Alright, once you do that, you can go ahead and set up 2-column notes on your next available page. A piece of paper. I am going to color code these notes, so if anyone would like colors to write with, just let me know. Anyone? Nope? Okay. So you're going to put the same heading at the top of your notes as you come on your table of contents page. A little crazy. So the title should be Multiplying Monos to Polys. Alright. So, let's do this. The main skill we're going to be working with here, okay? So when we were adding and subtracting polynomials, what skill were we really working on? Combining like terms, okay? So this skill is also kind of going to mirror something that we learned in Unit 1. Again, if you look at your Unit 1 table of contents, all of these skills, so we just did combine like terms, now we're going to go back today to the distributive property, okay? So, again, the main skill is the distributive property. But now we're going to be combining it with the laws of exponents. So think attaching it with the product rule, okay? I'm actually going to put that in parentheses. That might be valuable. In addition to the product rule. So not in your notes, we're going to do an example of the product rule here. This you do not have to write down. we have 2y cubed times, we'll do 7y to the 7th, okay? So this is an example of the product rule. What happens in this problem? You can start in two different places. Who would like to go first? I probably will only need 2 people. Brendan?
Multiply 2 and 7.
Right, so those coefficients get multiplied, so 2 times 7 is?
14.
So we have 14. Now what do we need to do? It's someone new. Right, so the base here is going to be y, so we have to keep the base and add the exponents. So 3 plus 7, so it gives us, okay, so we have y to the 10th, 14y to the 10th. Okay? So that's an example of the product rule. So we're going to be using this skill alongside the distributive property. Back to the notes. No, it's still recording, even though it looks like it's idle. The screen just went black, so it can conserve energy. Okay, so what I want you guys to remember, and we're going to actually make this a main idea, so very crucial to remember what we write next. So when multiplying monomials, and what is a monomial? It's an expression that, finish that phrase. So again, a monomial is an expression that right, so it has only one term, okay? Whereas a binomial has 2 terms, trinomial has 3, and a polynomial usually has 4 or more. Sometimes, though, when we get to something bigger than a monomial, we kind of just do a general grouping of a polynomial. So I could technically classify a binomial, a trinomial, and a normal polynomial all as polynomials, okay? So when I say we are multiplying monos and polys, we could be multiplying a monomial to a binomial in actuality, okay? But it could also go up to more than 4 terms, so just keep that in mind. So again, remember when multiplying monomials, you multiply the coefficients and add the exponents. I'm going to underline multiply and add in those 2 spots. The exponents of like bases. And then underneath, once you're done, I might write in parentheses the product rule, because that's technically what we're talking about. If you feel like you need a better visual example of the product rule, you can write that example from the board down on your page right around here. I am not, so I don't think that everyone needs it, but if you think you do, go ahead and write it in. Alright, so we're going to go straight into examples of multiplying a monomial to a polynomial. Again, I think many of you guys will find this skill easier than subtracting polynomials from polynomials. Alright, so here's going to be example number 1. I'm doing it in blue. So we'll start off with a pretty short one. So let's start with 5x. And we're going to multiply 5x to a binomial, technically, 2x plus 6. So some of you guys have actually done this before when we did the distributive property, okay? But now you have a better understanding as to what x times x is, because technically both of these bases of x have 1 as an exponent, all right? So I'm going to distribute 5x to the first term. What's 5x times 2x? 10x squared. Okay. Now I'm going to distribute 5x to positive 6.
How would you score that?
Because technically, again, we have x times x.
Oh.
And those have invisible exponents of 1. So we add the 1 and the 1 together. Okay? And so 5x times 6 creates what?
30x?
Yeah, 30x. So you just do 5 times 6, and then you tack on the x. So plus 30x. That's it. That's all you gotta do. That one's a very simple one, so now we're gonna take it up a notch, okay? I am going to switch colors. So here is example 2. So we're going to distribute a monomial to a trinomial now. The monomial is negative 2y squared and we're going to multiply that by the following trinomial. 3y squared minus y plus 6. So this one I'm going to fully write out just so you guys can see the process in a little bit of a different way. But again, this next step that I'm going to show, typically people wouldn't do this because it takes time and you have to write more, okay? So again, I'm going to multiply my monomial of negative 2y squared to my first term. So we have negative 2y squared, and I'm going to write that down, 2y squared, and I'm multiplying that to 3y squared. And I'm going to close my parentheses. And now I'm going to go back to my monomial, and I'm going to distribute to the second term of negative y. So I'm going to write minus 2y squared, and I'm actually going to put this in parentheses as well, because that is a negative term, and I'm going to put a plus sign in between them.
Wouldn't it be 2y cubed because you'd be adding?
Yep. Right. I haven't put the answers down yet. We're going to do that in a moment. I'm just distributing right now. Okay. So we have negative 2y squared times the negative y. But yeah, Brennan, you're on the right track. So I'm just showing that I'm multiplying this to every term within my polynomial. All right, I'm going to do another plus sign. Again, I'm going to write my monomial. So negative 2y squared. And that's going to get multiplied to positive 6. So if you're looking at this, here is my first set of distribution, here is my second set of distribution, and my third distribution. So now we're going to simplify that. We have negative 2y squared being multiplied to 3y squared. So what's my new coefficient?
Negative 6y to the fourth.
The negative 6 is the new coefficient. Base of y is still the same, and again, the exponents get added. 2 plus 2 is 4. So I put my plus sign down. So I'm going to bring this directly down. So negative 2y squared times negative y. Olivia, I'm going to come to you. I want you to try this one, okay? Negative 2y squared times negative y. What's going to be the new coefficient? So we have the coefficient of negative 2 right here, and then I have a negative sign right here.
Positive?
Yeah, so positive,
3.
not 3,
2.
2. Why is it only positive 2?
Because if you multiply a number with 1, it will usually come out as that.
Right. So technically this negative y has a coefficient, that's not right, of negative 1. But all we see is a negative sign, okay? So negative 2 times negative 1 is just positive 2. So 2y. And Brendan, you said what's the new coefficient?
3.
3. Because I have 2 y's right here, y squared, and then I have another y right here, so that's y cubed. Kyle, I'm going to come to you next, if that's okay? Alright, so we're going to do this last set of multiplication. So we're looking at negative 2y squared times 6. So what's the new coefficient going to be? Negative 2 is the coefficient here, times 6.
4y.
Don't add them.
Okay.
You're adding. We're multiplying, okay, because we're distributing. So what's negative 2 times 6? What's 2 times 6?
12.
What's negative 2 times 6?
12. I'm not sure.
Negative 12, okay? So we're going to subtract 12. Does the exponent of y here change? No, it does not. So negative 12y squared. None of these can be combined, so this is the simplest answer we can get. And they're already in order, from highest exponent to lowest exponent. All right, let's do one more example. What time is it? It is 8:23. This is such good timing, you guys. All right, example 3. This one, I'm going to, again, take it up a notch, okay? Example 3. So we have a to the 4th power minus 6a squared minus 16, right? So that is a polynomial that is not in parentheses, okay? And now I'm going to put a polynomial in parentheses. So we have 3a squared minus 7a plus 2. All right. This one looks slightly different than the last two because explicitly there is no monomial directly by itself. We have 3 terms right here, okay? So think about it. No one say anything. But what is the one piece that is going to be distributed here? Think about that. What's the one piece that's going to be distributed here? And I want you to say it out loud, but I'm glad you got it, because you're right.
Oh, sorry.
No, that's okay. I mean, I was eventually going to ask someone, so you at least save me having the hassle of having to ask someone. So 16, she's right, but what also with the 16? The negative sign, okay? So I'm going to just circle all of negative 16, because I want the whole thing to be distributed. So I'm going to do my, I don't know what else to call these. I just call them my rainbow lines, because that's kind of what they look like to me. All right. So with that being said, someone else, is a to the 4th minus 6a squared going to change right now? No. So I'm just going to bring those down. A to the 4th minus 6a squared. And now we're going to distribute. So what is negative 16 times 3a squared? You might need a calculator for this. Negative 16 is a bigger number.
48.
Alright,
A2.
good. Negative 48a squared. Now I need to multiply negative 16 times the negative 7a. So we need to multiply negative 16 and negative 7.
40.
Good. So we have positive, but we have to identify that it's positive. Okay, two negatives make a positive. So plus 112a. And then the last one we have is negative 16 times positive 2. What kind of sign am I going to need there? Negative. And what is 16 times 2?
Negative 32.
Beautiful. Alright, we're not done yet. What can I do to make this expression, this polynomial, shorter? More concise. Combine like terms. What are the terms we can combine, Sylvia?
Negative 6 a squared. Negative 48 a squared.
And that's it, alright? So we still have a to the power of 4, and we have negative 6a squared minus 48a squared. How many a squareds do I now have?
54.
Good, negative 54a squared. Again, we're just subtracting the coefficients there, not the exponents, okay? And then everything else gets written as is. Plus 112a minus 32. That's our last example in our notes. So we're still using combining like terms, but again, the main skill that now we're transitioning to is the distributive property. And the reason why is because we're working our way up to double distribution, where we actually distribute a polynomial to another polynomial, all right? And that's going to bring us to actually how we make polynomials, okay? All right, so since this is done, I do want to give you guys an option for games, because I do want to practice the skill. And I'm going to pass out whiteboards for whatever game we decide. We have as options Quizlet Live, Kahoot. We could also do something that's not attached to this skill, but attached to the unit and do that vocab, what's that, catchphrase game. What would you guys like to do?
I'd say Quizlet Live.
Quizlet Live has a vote. Kahoot has a vote. We're neck and neck. Maybe Kahoot.
No,
the vocab game. Sylvia, you're gonna be the tiebreaker. Yeah. What would you like to play? Kahoot it is. Poor Joe. Joe would be so happy to be here and play Kahoot. Alright. So Brendan, would you do me a favor and would you grab whiteboards? Olivia, would you do me also a favor and grab the markers and the erasers? Everyone should get one on top of the fireplace. Yep. You do not need rulers. So if you would collect those for me, you can put those in the jar.